Math 2, Unit 8, Worksheet 1, Properties of Exponents. So I want to review all of the properties of exponents real quickly. So the first thing we want to talk about is x squared plus x squared. This really isn't an exponent property, but it's important to start here because you need to understand when we are adding like terms, x squared plus x squared. Those are like terms. They're both x to the same power, have the same exponent, and these are just things. If you have an x squared and I have an x squared, together we have 2x squared. Do not make the mistake of adding exponents here. You add exponents when you multiply. If we have x squared times x squared, when you have the same base, you add exponents. So x squared times x squared is simply x to the fourth. When you multiply the same base, you add exponents. And that could be if we add 3 to the fifth times 3 to the seventh. That is simply 3 to the 12th. When you're multiplying the same base, you add exponents. Any questions there? Okay? Yes?
Can I do like 3 to the, oh, wait, no.
Okay. All right, so same base, you add exponents. Now, I'm going to go a little out of order here, but one of the things we usually show you, usually it's third, we'll say that x squared raised to the third power. So the simple answer is when you raise a power to a power, you multiply exponents. So this would be x to the 2 times 3, which is x to the 6th. Okay, when you raise a power to a power, you multiply. Now, why does that work? Because if you think of x squared to the third power, what that means is x squared times itself 3 times, or in other words, x squared times x squared times x squared. And now we're back to our first step, which was when multiplying the same base, you add exponents. Okay? And I really didn't get into a real explanation of that, but just like up here, x squared is really x times x, which means x times x, which means x times x. And what we end up with is x to the 6th. So that's a little explanation of why we add exponents. 2 plus 2 plus 2 is 6. Okay, so that's an explanation of the first two properties of exponents. Any questions so far? Okay, so when multiplying the same base, you add exponents. 2 plus 2 is 4. When raising a power to a power, you multiply. 2 times 3 is 6. And then the next one is when dividing the same base. When dividing the same base, you subtract exponents. X to the 5 minus 2, which is x to the third. When dividing the same base, you subtract exponents. You subtract the bottom from the top. I don't want to spend a lot of time on this, but if we go back to expanded notation, the reason this works is because x to the fifth is really x times x times x times x times x. X to the second is x times x. And reducing, we could reduce those three, and what are we left with on top? X to the third. Okay? For you. Okay. Jordan?
Evan.
Or Evan? Okay. That's Evan, okay. Pass it down to Evan. Okay. Moving on. What are we going to do next? Okay. So, and this is why, what does x to the 0 power equal?
No, wait.
1. Anything to the 0 power equals 1. And here's why. So x squared divided by x squared. What does that equal? 1, right? Isn't the rule anything over itself equals 1? 5 over 5 equals 1. 7 over 7 equals 1. Right? The rule you should have learned is anything over itself equals 1. Right? Yes?
Yes.
Okay, but if we take the subtraction rule we just talked about, and I kind of proved real quickly here, and I say x to the second divided by x to the second, which we already agreed that anything over itself equals 1, well, we go with our subtraction rule, 2 minus 2, x to the 0, right? So that's just kind of proof that anything to the 0 power equals 1, because if you come up with a 0 power, it means it started off something like this, and anything over itself equals 1. The same base raised to the same power is got to equal 1. Okay? Does that make sense? Anything to the 0 power equals 1. 5 to the 0 power, 1. 37 to the 0 power equals 1. X to the 0 power, 1. Y to the 0 power, 1. Stickman to the 0 power equals? Stickman to the 0 power equals?
Stickman.
1. Anything to the 0 power equals 1, right? Okay. So the last thing, and the probably maybe something you're not too good at, you don't remember too well. If we take x squared divided by x to the 5th, and we follow the subtraction rule, when dividing the same base, subtract exponents, the bottom from the top, we go x to the 2 minus 5, and we get x to the negative 3. Well, what does that mean? X to the negative 3 power. What's a negative 3 power?
I feel like I remember. Isn't it when you put like that over 1?
Ooh, you're close. Under 1.
Under 1?
Yeah. Negative exponent basically means reciprocal. Reciprocal. So, what is the reciprocal of x to the 3rd? 1 over x to the 3rd. I know that's what you meant. Okay? So, let's say, what if we had m to the negative 5? Well, the reciprocal of m to the 5th is simply 1 over m to the 5th. Does that sound familiar? You guys, I know you learned it in Math 1 because I just taught it to my Math 1 classes yesterday. And we reviewed it today. So the easy rule, which most teachers will say, is something like this. Since it means reciprocal, you're going to need to think about, whenever you see negative exponents, think about a top and a bottom. Okay? For instance, like m to the negative 5, we want to think about that as on top because we can always put it over 1, right? So m to the negative 5 was on top. It's the reciprocal, so I moved it to the bottom and made the exponent positive. So that's all you need to really learn. A to the negative 5. A is on top, so when I see negative exponents, I automatically put a division bar. I say A is on the top, so A to the negative 5 has to go to the bottom and become positive. Then I look at B to the negative 3. Well, the negative exponent tells me if it's on bottom, it's got to go to the top and become positive. And that's really all there is to it. So let me give you one that's a little more challenging. Let's say we have negative 2, x squared, x to the negative 2, y to the second, z to the negative 3, all over y to the negative 3 z squared. Okay, so you guys try and simplify that. And if you can do that, you probably have negative exponents down well enough to move on.
Wait, it's negative 2x to the negative 2 power, and y is what?
Y is to the second power. Z is to the negative 3 power. Down below, y is to the negative 3 power, and z is to the second power. So remember, if you come across a negative exponent and that variable is on top, you move it to the bottom and make your exponent positive. If you come to a variable with a negative exponent on the bottom, you move it to the top and you make that exponent positive. Now, don't get the negative exponents confused with a negative number. A negative number is just what it is. It's a negative number, you leave it alone. Now, if a number has a negative exponent, well, then you would move it to the appropriate place. But you just don't move a number because it's negative. Negative exponents are different from negative numbers. Negative numbers have a value. Negative exponents just tell you reciprocal. No, that negative 2 does not move. It doesn't move. That's exactly what I'm talking about right now. Negative numbers are not affected unless they're next to a negative exponent.
So the x, like, well, so you leave the negative 2 there, but you bring the x to the negative 2 down. To make
Yeah,
the x.
yeah.
Okay.
Remember, the 2 and the x are not connected. None of these things are connected. One of the things I try to get through to my Math 1 students is you have to think of these things as all of them are separate. Have you guys all had a chance to give it a try? Okay, so what I try to get my Math 1 students to understand is put parentheses around all of these things. They're all little separate pieces, all little things that are being multiplied together. And then look at them one piece at a time. So I have negative exponents. So I go ahead, whenever I'm doing a problem with negative exponents, I just go ahead and I put a division bar there because I know things are going to be moving up and down. The negative sign doesn't have an exponent at all, so it's just going to stay right there. It is unaffected by negative exponents. Now 2 doesn't have an exponent, does it? So it will stay right where it is on top. All right, x to the negative 2. Negative exponent tells me if it's on top, move it to the bottom and make the exponent positive. So what I do is I kind of just move across and I kind of cross these off as I go on. Y squared, that's a positive exponent, so I'm going to leave it right where it is. Done with that. Z to the negative 3 power. Negative exponent tells me if it's on top, move it to the bottom and make the exponent positive. Okay, so I just worked my way across the top. Now I'm going to do the same thing at the bottom. Y to the negative 3. Negative exponent tells me if it's on bottom, move it to the top and make the exponent positive. Done with that. Z to the negative 2 power. That's a positive exponent, so I will leave it right where it is. So I moved everything. There aren't any more negative exponents. So now I simply combine, well, I won't say combine like terms. I simply multiply the same base. For example, negative 2 stays where it is. Y squared times y to the third, I add exponents, I have y to the fifth. X squared is all by itself down here, I'll leave it there. Z to the third times z to the second, bases are the same, I add exponents. Okay, how many got that right? Good, good.
Most of it.
All right, if you didn't get it right, do you understand where you went wrong? Okay, that's key. It's great that you got it right. But if you didn't get it right, can you at least figure out and find your mistake and maybe not make it the next time? Okay, so let's do a couple of examples, and then the rest of the period will be for you to finish up this worksheet. What you don't finish up is homework. And hopefully this, guys, this is stuff you did in Math 1. It should be a reminder. We've done some of it this year. We do it all the time. These are kind of basic math skills, basic algebra skills. All right, so the first one, 1 through 3, is just expand and evaluate. Well, 4 to the third is obviously 4 times 4 times 4, which is simply 64. Questions on number 1? All right, I think you can handle the next two. Let's go and do number 5. Okay, that is our first exponent rule. When multiplying the same base, add exponents. So I have 11 to the 7th. Don't forget that 11 right there is to the first power. Any questions on 4 through 6? Okay, I'll leave those for you to do. All right, 7 through 21, the biggest part of this worksheet. I'll do a few of these with you. It's really just multiplying. For example, let's do number 11. All right, well, 12 times 1 is just 12. Okay, we're multiplying m to the 5th times m to the negative 3. We add exponents. 5 plus negative 3 is m squared. And the n to the 5th is by himself, so he'll just come along and 12m squared n to the 5th. Okay? All right, let's go down and do number 13. We did that one, raising a power to a power. When we raise a power to a power, we multiply, don't we? So 2 times 4 is 8, so this is a to the 8th. Kind of a tricky one here. Well, we're raising a power to a power, aren't we? So this becomes k to the 1. Negative 1 times negative 3 is positive 3, isn't it? Okay. Don't forget here that it's 2 to the 4th and x to the 4th. So everything gets raised to the 4th. All right, let's move on. All right, I'll do number 20 for you. So again, we're just multiplying. So it's 4 times 2 is, oh, wait. I almost messed that one up. We're multiplying 4jk squared times 2j to the 4th raised to the 3rd. We're raising its power to a power, so we actually have to handle this first. It's order of operations. You handle exponents before you multiply, and this is really an exponent being raised to an exponent. So I'm just going to bring down my 4j squared, jk squared, and if I raise, remember, 2 is to the first power, so 1 times 3 is 2 to the 3rd. Raising a power to a power, 2 to the 3rd, or 2 to the 1st times 3 is 1 times 3 is 3, so we get 2 to the 3rd. And then j to the 4th raised to the 3rd, 4 times 3 is 12, so we get j to the 12th. Okay. Well, I got to take this one step further, because 2 to the 3rd is 2 times 2 times 2, which is 2 to the, which is 8, j to the 12th. And now we're ready to multiply all this together. So 4 times 8 is 32. J to the 1st, don't forget, that's to the 1st, times j to the 12th. 1 plus 12 is j to the 13th. And then the k squared just comes along. Any questions on number 20? All right. Number 22 through 30. I'll do number 27 and 30 for you. All right. So right now we're raising a power to a power. We could reduce this first and then raise it to the power, but we might as well just raise the power because that's the order of operations. So we have x to the 1st right there. So 1 times 3 is 3, so we have x to the 3rd. 7 times 3 is 21, so we have y to the 21st. 5 times 3 is 15, so we have x to the 15th. And 3 times 3 is 9, so on the bottom we have y to the 9th. I'm sorry, let me move that up a little bit for you. Okay. And now we can reduce, right? Because we have x's on top and bottom. When you have the same base, you subtract exponents. So you got a couple different ways. You could cancel. One way of going about this is I got 3 x's on top, right? If I cancel 3 off the top and I cancel 3 off the bottom, there are 12 left on the bottom, aren't there? I've got 21 y's on top and I got 9 y's on the bottom. If I cancel 9 off the bottom and 9 off the top, I'm left with 12 on top. Does that make sense? Okay. Now, yeah.
When you're like reducing it, does it matter if y goes on or x goes on top or y goes on bottom?
Yeah. Yeah. Look at I have 9 y's on the bottom, 21 on top. I got to have, if I take 9 off the bottom and take 9 off the top, where are they going to be left over? On top, right?
Okay. Yeah, I see what you mean now.
Okay. So another way of doing that, if you can kind of see through my marks here, if I had went this way, I could have said, hey, x on top and bottom, that would be x to the 3 minus 15, which is, okay, and then y to the 21 minus 9. And what do we end up with? I know I'm kind of going about this out of order, but if I continue up this way, this would be x to the negative 12, y to the 12th. And what you can see here is, if I did it by subtracting, I get x to the negative 12, which means I would move it to the bottom, wouldn't I? Okay? All right. Now I want to do this one other way for you guys. I could have reduced this first. So I could have said, hey, I got 1x on the top and 5 on the bottom. So if I cancel 1 off the top and 1 off the bottom, I'm left with 4 on the bottom. I've got 7 y's on top and I got 3 y's on the bottom. If I cancel 3 off the bottom, it leaves only 4 on top. And then I have y to the 4th over x to the 4th raised to the 3rd power. 4 times 3 is 12. 4 times 3 is 12. And you can see we end up with that same answer, don't we? So whether you reduce the inside first and then raise it to that power, or whether you raise the power and then reduce, it's up to you. Okay, are we good with number, whatever that was, 27? No problems there? Okay, so let's go on to number 30. So we have negative 3x to the negative 2. So again, like I tried to point out, you want to treat these as separate things. So the negative 3, that doesn't have a negative exponent, so it just stays where it is. The x to the negative 2 goes to the bottom, and we make it positive. There's your answer. That's all you can do, basically. Okay? All right. Number 31 and 32. There are, I'm going to be honest with you, several questions like this on your test. And they kind of get confusing, but if you understand the process, it's really pretty easy. Okay? Let's see.